Hello, today I'll be doing Chapter 8, Problem 31. I love this problem because it bridges together the previous chapter, which was Chapter 7, and this current chapter. So, let's get started. A model airplane with a mass of 0.75 kilograms is tethered by a wire so that it flies in a circle 30 meters in radius. The airplane engine provides a net force of 0.8 newtons perpendicular to the tethering wire. Now here's our three questions. Find the torque the net thrust produces about the center of the circle. Find angular acceleration of the airplane when it is in level flight. Find the linear acceleration of the airplane tangent to its flight path. Let's get started. Here I already drew out our model, or a lovely airplane here, expertly drawn, going about in a circular path. And here's our wire at a perpendicular angle, as you can see here. And it's going around here. I've already labeled the positive and negative axes, so let's get started with one. One is just a simple torque problem. You just set it up the simple. You just set it up with simple torque equals radius times force at a specific sign. You just plug in 30. You just plug all your variables in, 30 meters times 0.8 newtons times the sine of 90 and get 24 newton meters. Next, B. B is a little bit more complex because you're going to have to incorporate these two equations. But it's simple once you get the hang of it. First, I laid out the equation. Inertia equals mass times radius, and torque equals inertia times angular acceleration. Substituted each equation, plugged in my variables, and got an angular acceleration of 0.036 radians per second squared. Number C is going to be very hard if you don't remember Chapter 7, but just go back and reread Chapter 7. So Chapter 7, we just use linear acceleration equals radius times angular acceleration, plug in our variables, and get that acceleration equals 1.008 meters per second squared. I hope this was helpful to you. Bye!